talk about fine particulate matter exposure from wood-burning cook stoves in relation to augmentation index and blood pressure among Honduran women. So the objectives of this presentation are, I'm using data from a cook stove intervention study, and I'm just going to evaluate the baseline associations between exposure to PM2.5 and two health outcomes, blood pressure and augmentation index, which is an indicator of arterial stiffness. So the background, as you know, the emphasis has in previous cook stove and household air pollution studies has been more on respiratory health outcomes, but since cardiometabolic diseases are on the rise in many low and middle income countries, now more and more studies are done, including cardiovascular disease outcomes. And many studies so far are actually focused on blood pressure, and there have been associations observed and reported. Augmentation index in this study is more of a novel indicator. It has not been evaluated in many air pollution studies. So, and yeah, that's why there's not that much known about it yet. So just to give you a little bit of an idea what augmentation index is, it's an independent predictor of mortality and of cardiovascular disease risk, and it's a measure of wave reflection. So as on the left, you see a blood vessel, and as the wave travels through the blood vessel, it may encounter like an obstacle, such as the bifurcation, and then the wave is reflected. And the faster the wave is reflected, the stiffer the vessel is, and then this reflected wave is even higher than the initial wave. And when you divide the reflected wave by the initial wave and then multiply it by 100, that's when you get this augmentation index. So there are, on the upper right, you see three different waves. On the left is more of a young person with a slower reflection. In the middle is a middle-aged person, and on the right you see an older person with a very fast reflection that indicates higher stiffness. So we want our augmentation index to be as low as possible. This is the study design. It's a longitudinal intervention study. We recruited 230 women. All of them initially had traditional stoves, and we randomized them into two groups. The first group received the intervention stove, which was also a cleaner burning biomass stove, so still biomass, not LPG or electric stove. The first group received that stove after 2 visits, and the second group after 4 visits. We visited the women every 6 months, but actually I need to emphasize that today I'm only talking about results from the first 2 visits, so when everybody still had their traditional stoves. We did 1 visit in the rainy season and 1 visit in the dry season. Our study site was in 10 communities around La Esperanza in western Honduras. It's a hilly region on 1,700 meters, and it's a cool climate and fairly safe. Our study population were 230 female primary cooks. They were between 24 and 49 years of age. They were all not pregnant and not smoking, and they all had traditional stoves. These 2 pictures on the right depict typical traditional stoves in Honduras. Usually there is a plancha, a griddle, which they need to cook their tortillas. That's one of the characteristics of these stoves. We measured exposure to PM2.5 using sort of a standard setup of pumps and cyclones. We hung one set into the kitchen above the stove at around 70 centimeters from the stove edge. And we also did simultaneously a personal measurement where we put the pump into a bag, which the woman then wore for 24 hours. We attached the cyclone to a strap onto the bag strap near the breathing zone, and she wore it and just took it off for sleeping, bathing, and breastfeeding. We measured health, both augmentation index and blood pressure, with the same device, the SphygmoCore XL. We measured health immediately after the 24 exposure measurement period between 7 a.m. and 12 p.m. The woman was resting for about 10 minutes, then we did 3 consecutive blood pressure measurements. Each one was 1 minute apart, and the average of the last 2 was then taken into account for the analysis. As to results, these are all pre-intervention. As I said, PM2.5 was fairly high, both kitchen and personal measurements. Kitchen are obviously usually higher. They are at around 200. The median is at around 200 micrograms per meter squared, of course, well above WHO guidelines. And correlation was fair between phases 1 and 2. So to speak, between the rainy and the dry season. For kitchen, it was the Spearman's row was 0.53, and for personal, it was 0.4. And it was a little higher when comparing within the phases, kitchen and personal within the phases. Pre-intervention health outcomes, as you can see on the left, you have in blue the systolic blood pressure and in red the diastolic blood pressure. So all our women actually had fairly low blood pressure at the beginning of this study already, and there are no real standard values for augmentation index. So I can't really tell you if this central augmentation index is higher or lower than what is recommended. Correlation between systolic blood pressure between the 2 phases was fairly high, also for diastolic and augmentation index, but as you can see on the right, augmentation is really completely independent from blood pressure, so correlation between blood pressure and augmentation index is actually very low for both systolic and also for diastolic. We then ran mixed effects regression models and log transformed exposure, and we found a coefficient, the adjusted mean difference in systolic blood pressure per log increase in pollution was minus 0.81 for kitchen PM2.5. This is systolic blood pressure, and in relation to personal PM2.5, it was minus 6.7. And for diastolic blood pressure, we found a decrease of 0.28 and 0.78 for personal. We adjusted all these models for age, years of school as a measure of socioeconomic status, waist-hip ratio, dietary diversity score, salt intake, physical activity, and mean kitchen temperature. So all these effects are actually not in the direction we had hypothesized, but they are also not statistically significant. Now, with augmentation index, we also found a coefficient of minus 0.3 for kitchen PM2.5 and minus 1.52 for personal PM2.5. We removed 2 large outliers in this analysis, and in addition to the other covariates, we also adjusted for height with augmentation index. But as you may have noticed, these effects aren't in the hypothesized direction either, and they are actually even statistically significant for personal PM2.5. So to summarize this again, the elevated personal PM2.5 in our study at baseline was actually associated with a lower augmentation index. These results, although not statistically significant for blood pressure, are not in the hypothesized direction. However, these changes are small and they may not be biologically or clinically meaningful. These blood pressure results are actually not consistent with existing literature, and it could be that augmentation index may not be a meaningful indicator of long-term exposure to household air pollution. Another indicator of arterial stiffness is pulse wave velocity, which is often measured, and that's more of an indicator of long-term exposure. So it could be that may yield different results when measuring pulse wave velocity. Unfortunately, it was a little difficult in our setting to do that. We had planned it initially. Our results may be consistent with this hypothesized supralinear exposure response curve between household air pollution, cardiovascular diseases, which suggests weaker or no association at higher concentrations. So you see on the right, as the exposure gets higher, this curve actually flattens out. So maybe this is another explanation, even though why our results would be contrary to our hypothesis. This isn't explained by this curve either. So I would like to acknowledge my team, especially Dr. Maggie Clark, who was my supervisor these past 4.5 years, and it's actually today my last day of work with her, so thank you very much, Maggie. And if you have questions or comments, I'd be really interested in hearing them. Thank you very much.